So exercise 63, page 123, question number 1. I've written down the two pieces of information for you to start you up on this question algebraically. If you look at the first equation we've got here, that's in algebraically writing down the first piece of information we have. We're told that 9 times the third term equals the fifth term effectively. So the third term is AR squared and the fifth term is AR to the 4. So 9AR squared equals AR to the 4. So that's the first bit of information. Then a second bit of information we're told is that the sixth term plus the seventh term is 1944. So the sixth term can be written as this and the seventh term can be written as this. And so with those pieces of information we should be able to find A and R. And then we can find the sum of the fourth, the 10th terms inclusively. So let's see if we can work out how to go from there. See if you can. Equation number 1, I can rearrange that and solve it for R directly. And then once I've got R, I can put that information into the second equation to find A. So see if you can do it. So from 1, 9 AR squared is AR to the 4. But if I divide both sides by A, effectively the A's cancel. So I'm left with 9R squared equals R to the 4. Now divide both sides by R squared, we get 9 equals R squared. R squared, R to the 4 divided by R squared equals R squared. From the laws of indices, 4 take R to the 4 divided by R squared. Base is the same, so you subtract powers. 4 take away 2 is 2. So I've got the R squared equals 9, so R equals the square root of 9, which is plus or minus 3. Well, we're only interested in possibly the positive solution, but it's possible it could be minus 3. No, it won't be minus 3, will it? So plus 3, so R equals 3. That's the common ratio. So now we know R is 3. We can put that information into the second equation. So putting this into 2, which is that AR to the 5 plus AR to the 6 equals 1944. So we've got that. I can take, making life a bit easier for ourselves, I can take R to the 5 outside a bracket here, leaving A plus AR. In fact, I can take AR to the 5 outside the bracket. So AR to the 5 into 1 plus R equals 1944. I can now divide both sides by R to the 5. So A into 1 plus R equals 1944 over R to the 5. But of course now we know what R is. R is 3. So therefore A into 1 plus 3 equals 1944 over 3 to the power 5. So A equals 1944 over 3 to the power 5 times 4 effectively, because I divide both sides by 4 to get rid of that 4. And then I can put that into a calculator to find A. And A turns out to be 2. So that can go on and finish the question. I found the common ratio, the first term, and can I find the sum of the 4th to the 10th terms inclusive? So if you find the sum to the 4th term, well, sum as far as the 10th term, and then the sum as far as the 4th term, and subtract one from the other, or sorry, sum as far as the 3rd term, because it's including the 4th and the 10th, you'll be able to find the answer in the text, hopefully.